Hi guys, it's Dr. Orlando again here with atomic shell models. I'm going to go ahead and show you how to draw one. Make sure that we're all on the same page here on how I want them drawn. Okay, so when you look at the periodic table, you will see something like this little tile here. This one is Na, which is sodium. Abbreviation is Na. This number at the top, 11. Let me get another color here. This is what we call the atomic number, and it is the number of protons, positively charged particles in the nucleus. Down here we have the atomic mass, which is going to be equal to the number of protons plus neutrons plus electrons. Okay, and this is a weighted average, as we talked about, because sometimes many times these elements exist as isotopes, remember, having different numbers of neutrons. So those smart scientists figure out a weighted average for this atomic mass that would include all of those isotopes. Okay. All right. As a rule, if the atom does not have a charge, which it should not if it's on the periodic table, then protons will always equal the electrons. Okay. So I like to, and neutron number is going to equal the atomic mass. I'm going to do AM minus atomic number. So you take this number, 23, and you subtract 11, okay, to give you the number of neutrons that would be in the nucleus. Okay. All right, so to draw a shell model, the first thing you're going to do is draw the nucleus. And I like you to put the number of protons, P plus equals 11, and the number of neutrons. Remember I said that the neutrons equal the atomic mass minus the atomic number, so that's going to be 23 minus 11, which is going to be 12. Okay, so that's the nucleus of the atom. That's the center where those subatomic particles reside. Now, in these atoms, we have electrons that are flying around the nucleus in shells. And we are going to learn a very simple way to fill the shells. So here's some rules. So the shells are filled from innermost to outermost. Okay. And as far as how many electrons go in each, we have, these shells are also referred to as orbitals. So in the first orbital, okay, you're going to get 2 electrons. In the second orbital, you will get 8 electrons. In the third, you're going to get 8 electrons. And then in the fourth, we don't have any that we have to learn that will fill the fourth, so we're just going to say in the fourth you do the leftovers. Okay, we just don't look at elements that are that big in biology, at least not in our class. Okay, so we're going to go ahead and draw the electron shells now. So we're going to draw the first one. And you may recall I said that the electrons, we're going to make them blue. In the first orbital, we have 2. And electrons like to pair up, so we draw them as buddies. So the first orbital gets 2. That one's full. Move on to the next orbital. I said that this one gets 8. And again, these guys do like to pair up, but they don't pair up until you get 4. So do 1, 2, 3, 4. 5, 6, 7, 8. Okay, if you do them that way, you'll pair them up the right way. Let's say this second ring had 6 in it instead of a full shell, then you would pair them up correctly that way. Okay, so this shell is full because it has 8. Okay, now we're up to 10. Okay, and we have to get to 11. Remember, I should take a step back here. Protons equal electrons, so we have to have 11 electrons, and we only have 10. So let's go with one more ring. And in this ring, we've got one lonely little electron. Okay, I don't know why I drew him bigger. He's now no bigger than the rest. Okay, and then I always like you guys to label it. You can put the abbreviation there as well. And then that atomic shell model is done. So you can always follow that pattern with the ones I give you in class, and you will do well. If you have any questions, please feel free to call me or email me. Have a good day.